Okay, this is my second time recording this one, and that's just because I made a small mistake when I was doing the original one. Like it was done, I was like about to post it, and then I was like, wait, is that correct? Let me double check. And the issue I made was I said that power is equal to the rate at which force is applied. That is not correct. Let me just like go through and fix that real quick. So this is a box, and it's the question is saying that over time, a constant force of F is being applied and it's delivering power, so P. And this causes the object to move at an average rate. So I'm going to say V average. But honestly, this is not really relevant to like the actual answer. Um, but anyways, it's just asking us like what the magnitude of the force is. So like what is F equal to? So like I was saying before, I said that power is the rate at which work is be or the rate at which force is applied. That's not correct because it's actually more so that power is equal to the rate at which work is applied over time, um not force. So power is work over time, not force over time. And in reality, work is actually just equal to force times displacement. Um, over change in time. There should be a multiplication there. So technically, force is related to power, but it's force times displacement, which is equal to work, when work is equal to power when work is over time. So saying that force or power is the rate that which force is applied over time is pretty disingenuous. And it kind of skips out on the whole displacement thing, which is pretty important. And this is also like we've done this before, just because when we're solving like general energy questions and we have like work is equal to EF minus E initial, sometimes we don't know what the work is, but we do know what the force is. So we just kind of end up doing F change in displacement is equal to EF minus E initial. Like this is the same equation, which goes to show that these two are like fully interchangeable. And that's what's going on here, right? So then this ends up being equal to F times V average. And that's because I mean, like, if you look at this, right? Like change in displacement over change in time. Um what is it? Times force, that's just gonna be equal to force times velocity, right? So average is what if you want to do that, just so it lines up there. But this can essentially just be reduced down to this, is what I'm trying to say, right? And that's just like with pre-existing knowledge that oh wait, displacement over time is velocity. But yeah, so this is what we get, and then this we just have to kind of put into terms of F. So if F times V is equal to P, we just got to divide by V. So then F is going to be equal to P over, and this will be our final answer, which would be B. Um, but yeah, I mean, at least to me, power is a little bit newer, so that is my bad. I messed up there. But just kind of keep in mind that power is the rate at which work is being applied, and then work is force times displacement over time. So it's not like a direct link, like don't just assume that it is. Um, Everything seems to tie back to work, I suppose. So